option has been removed. So if you upgrade to 6.3, you'll see a lot more warnings. Or actually, the goal is to have people remove all the warnings, the compiler warnings. So that's the purpose of making this change. There was a minor change to the developer's certificate of origin that clarifies that if you're a kernel developer and you're well known, you can actually use a nickname instead of your legal name for contributions. In 6.4, the SLOB memory allocator was removed, and I'll talk more about that later. There was some nice documentation added for building the kernel. And I think most people know how to build the kernel, but now there's some kind of nice documentation upstream with some quick tips on that. The module license declarations, a lot of those were removed if it was used in code that cannot be built as a module, and there's kind of a long history there why code that couldn't be built as a module was actually using this macro. But that was a cleanup that it turned out to be trickier than people thought. User trace events, API fixes was merged in the 6.4 release. In 6.5, something having to do with boot time, which was parallelizing the bring up of CPUs, was introduced. So you can now bring up bring up CPUs in parallel instead of sequential during the boot cycle. And that helps reduce the time to get all the processors online. So a little bit of an improvement in boot time. Currently, this is only on x86, but I think other architectures will pick this up. There was actually a big reorganization of the 32-bit device tree file directory structure just to make it match the 64-bit other architectures. And so that's good. I'm a little bit worried. I'll cover this when I talk about it later, but I'm a little bit worried about ARM32 and how long it'll continue to be supported. I think there's a lot of developers still using it, and we need to make sure that upstream architecture maintainers know about that. There were some miscellaneous ftrace and perf updates in this release. Seems like there's always some perf updates. In kernel 6.6, this was from October, you can now build a kernel without buffer head support. So buffer heads is a data structure in the kernel that has to do with managing memory. And there were some people who wanted to eliminate it using IO maps and folios. But Linus was not too fond of this patch, but it did end up getting in. It's possible through a config item to not use this if you're using other sections. So this has to do with the memory subsystem. There was a new pseudo file system introduced called event.fs, and this improves the memory efficiency of the tracing subsystem. It only allocates inodes, missing a D there, and D entries for trace points when they're used. So this is a little bit more efficient. And then shadow stacks, which is a nice security feature. So let me talk about shadow stacks. This is a fairly important new feature that's available currently only on x86. This landed in the 6.6 kernel. There are patches being developed for 64-bit ARM and RISC-V. But the way this works is there's now two stacks that have return addresses on them. The main stack that's used by the program normally combined with data, but there's also return addresses put on a second area of memory called the shadow stack. And this is often managed by hardware so that it's as fast as possible and there's extra security. What happens is that return address is compared when the processor executes a return. The shadow stack is the value that's on the shadow stack is checked to see if the return address is the same on the regular stack as on the shadow stack. And you can tell that way if the regular stack has been altered. So this is a very, very useful technique for detecting certain types of programming attacks called return-oriented programming. This is one of the main ways that people attack the Linux kernel, attack software in general, is trying to somehow manipulate the stack to return somewhere besides the original location. So this is, I think, a very interesting control flow integrity mechanism. So work is actually already in progress to support this. I believe the support is already in glibc, but I just noticed like 2 weeks ago that the Musil C library is also working on supporting this. So that's actually really good. And then in Linux version 6.7, this was, I think this was in January, you can now enable or disable 32-bit emulation on 64-bit kernels, well, at least on x86 64 kernels. And that actually is very helpful to reduce the attack surface. Some of that emulation for 32-bit code, well, it just presents a whole extra set of APIs that need to be secure. And by eliminating that, it removes a lot of attack surface. The Itanium architecture was removed, so additional architectures are get added and architectures get taken away. There's more efficient kernel same page merging, and I'll talk more about that later. And then PrintK now supports per console locking. So this allows high priority message output to take over the console from a lower priority message. And this is, I believe, part of the patches that are going in to support Preempt RT, the real-time patch set. This was important. I believe this was to prevent priority inversion. But in general, it's just a good system, so that if you have a high priority message, particularly one having to do with the kernel oops or something like that, you want that to override a low priority message. Okay, and then the last kernel I'll talk about really quickly here is Linux version 6.8. And we're currently on the RC7 release, so release candidate 7. So we're 7 weeks into the testing phase of this kernel. Like I said, it could the 6.8 kernel could be finalized as early as Sunday, Sunday in the US. But Linus said something about there were some things that came up late in the release cycle that he said might add an extra week. So it'll either be this Sunday or the following Sunday. So a couple of things in this release was something called deadline servers has been added. And this prevents real-time tasks from completely starving normal tasks. I actually have a slide on this. I'll talk about it. The first real Rust driver was added to the kernel. So if you're aware, the people have been working to support the Rust language so that people can write code for the Linux kernel in Rust as well as in C. And there was a reference driver that was added. And this is the first example of real kind of functional, useful code in the kernel. And I'm going to talk about that a little bit more later when I talk about languages. So a couple of kind of efficiency things as well. So the networking core data structures were refactored so that they could improve network efficiency using the cache. And in some situation, this improved TCP performance up to 40%. So that's actually really good. The slab memory allocator was removed as well. Okay, so there used to be 3 main memory allocators in the kernel for a particular type of memory allocation. Slab, SLAB, SLOB, SLOB, and SLUB, SLUB. And 2 of them have now been removed over just the course of 1 year. So SLUB is the last one remaining in the kernel. Again, I have some commentary on that. So it was only within 6 months of the other one being removed that slab was removed. And slab is actually the original allocator for Power of Two memory. Um, anyway, and then finally the perf data type profiling was added in this release. Okay, so and then a lot of these I'm going to talk about later. I think right now I'm going to focus in on deadline servers. So if you're dealing with real time, there's a problem that you always have, which is that real-time tasks have higher priority than any normal tasks in terms of the scheduler. And so it was always a risk on a real-time system that real-time tasks could end up starving normal tasks. If you had a bug in your real-time, then you could end up with a system that you couldn't break into. And there were some mechanisms that Linux had. One of them was called real-time throttling that allowed you to fix that problem. But there were there were certain issues with how that worked. The system was supposed to reserve like 5% of the system CPU for real time, uh, for non-real time. So 95% out, up to 95% of the CPU could be allocated for real time, and 5% was supposed to be reserved. But a lot of times it was reserved, and even when it was not needed. So this new mechanism called deadline servers allows an admin to fix the runaway real-time task using a different mechanism. So this was added in 6.8. And how it works is that they now use deadline scheduling. So they set up a server that's running under the deadline scheduling priority, which is even higher than real-time priority. And that means that that server is in the background, and it normally is not running at all, but it gets scheduled when possible task starvation is detected. And then that deadline server takes some of its quantum, and it has a guaranteed scheduling quantum of up to 5%, and that runs normal tasks. So it allows you to detect it allows you the administrator to use that 5% to kind of recover the system in case something's gone wrong. And again, because the deadline scheduling is even higher priority than real time, that works. And because it started on demand instead of running continuously, it takes less overhead on the system. Anyway, if you want to read about that, that's a nice real-time feature that's been added. There's an lwn.net article. And then the other thing I want to focus in on has to do with the perf command. So the perf command is very versatile and allows you to see a lot of performance data on a system, and it can sample all kinds of things, cache hits, and the usage of the CPU performance counters. That's where it gets its name from. But there is a new subcommand that allows you to annotate the output based on data type. And in particular, you can mention a field name or a structure. So you can get actually per field data on a per field basis out of a data structure. So what this means is that you can say, well, how many times was this particular field accessed during a particular run? And it shows you the offset of the structure fields and the frequency of access. So this turns out to be very, very useful to see if you can move the fields around in the data structure to improve cache performance. So one of the things that you really want to do if you have a very highly accessed piece of data or a structure is you want to make sure that the fields that get accessed the most frequently are in the same cache line. And so this has already been used to fine-tune the kernel. A lot of the kernel work these days in terms of performance has to do with making sure that the processor caches are utilized efficiently. And so you can use this to check if a frequently accessed field is in a different cache line than some of the other fields in a data structure, or you can make sure that all of the frequently accessed fields are in the same cache line because you have the offset and the frequency next to each other. So this could be very useful for people who are doing performance tuning on the kernel. So people have been doing this type of performance tuning a lot to try to make the kernel as efficient as possible. But now this tool makes it a lot easier. Instead of kind of guessing and trying to run benchmarks, you can actually get some hard data about the number of accesses and where the fields are. So what fields are going to be hitting the cache lines. So that's actually pretty good. I'm not going to talk too much about this. A couple of community issues have come up in the last year. One of these is relatively old, but it keeps being raised. So there have been recent discussions about the threat of maintainer burnout. And this is a long-term problem with the Lynch kernel. The workload is very high, and the turnover is very slow for maintainers. There's not enough assistant or replacement maintainers. And actually this is the first time this has happened. There was actually a mental health session that was provided at Linux Plumbers for dealing with maintainer stress. So we actually had a psychologist come and talk to maintainers and record some information about how to deal with stress and burnout. And there was actually a session with the kernel leaders at Plumbers as well, discussing some of the issues involved. And then just kind of a housekeeping issue here with the kernel mailing list. Some of the lists moved from one domain to another that you probably this won't affect your reception of it, and then so the lists all point outward to the same thing. But if you are sending mail, you should double check and make sure you're sending it to the right place, because some of the lists for the kernel server mailing lists or the kernel mailing lists have changed addresses. So let's look at a couple of developer stats. There's a couple that are interesting here. This is for 6.6, which is the last time that I got data from lwn.net. Some of this data I get myself and some I get from them, but this particular page, so this is, I guess, one release behind, but you can see kind of what people are working on, who the people are: Christoph Kozlowski, Youngtao Lee, Conrad Dipsio, Rob Herring, and Thomas Zimmerman. And in that particular release, these people had between 150 and 300 change sets. That's a lot of change sets. And you can see there's a lot of device tree updates. The Youngtao Lee had a lot of change sets, but it was because he was converting a lot of drivers to use DevM platform IOMAT resource. So sometimes you have these changes that affect a lot of different areas of the kernel. So notice that the next two also: device tree files and Qualcomm drivers and device tree related code. And then the last one was graphics and frame buffer drivers. So three of the top five highest developers with the highest change sets are working on device tree things. So that should tell you that there's a lot of churn in the device tree section of the tree. Let's see here. Oops. And then that was by change set. This is by number of lines of code changed. So a little bit different metric. So Jiri Pirko with 17,000 lines of code, over 3% of this total of the changes for this kernel release were refactoring of the network subsystem. And so that could be that's that refactoring that I talked about previously, where they tried to change the data structures so that they were more cache friendly, and they got a big speed boost out of it. And then you can look at some of the other ones. You see Jiri Pirko is unaffiliated. We don't know who he's working for, but you see some of the normal organizations: Linaro, Google. In case of Cirrus Logic, the Charles Kepax just is working on an Intel sound driver, and that was big enough to make the top 5 list. If looking at recent kernels and how big they have been, It's fairly customary to have about 15,000 commits in a particular kernel and about 2,000 developers. We've been having very consistent number there. 6.7 was a little bit bigger in this last release cycle. I'm not sure where that came from. We didn't have a lot more developers. It didn't have the highest number of developers out of the most recent 6 kernels, but it had 18,000 commits, which is a little bit more. So I'm not sure where that extra came from. And then looking at embedded companies, this is by no means all of the companies that do embedded work, but these are just some of the kind of the consulting companies. So these are consulting companies. I haven't included like semiconductor manufacturers, right? So Intel and Qualcomm and MediaTek, they also have a lot of patches for their respective processors, but these are kind of the independent companies that are either doing support work for other companies or are helping companies upstream particular drivers. And this is kind of how many commits they had. Notice Lenaro really stands out here with 4,600 commits. Again, Krzysztof Kozlowski, he was mentioned earlier. He always has a ton because he's doing device tree work, but he has a ton of patches in other areas as well. He's a very, very active developer. Anyway, you can kind of look at the list and see the different things people are working on. MTV stuff, memory technology device stuff, lots of drivers, GPU drivers, camera, I2C, sound, clocks, print K. And anyway, so that's just kind of an overall view of what companies are contributing and what areas they're contributing in. Some interesting news this last year is that long-term support kernels, LTS kernels, we now have quite a few of them and not a ton of manpower to maintain them. I think mainly being maintained by 3 people, but we have I think 7 long-term support kernels, 4.14, 4.19, 5.4, 5.10, 5.15, 6.1, and 6.6. The idea now is to pick 1 per year and only maintain for 2 years. So previously, the kernel developers said they would maintain these long-term support kernels for 6 years. So some of these are going to stay on until their 6 years is up because the kernel developers want to keep their commitment there. But as some of these older ones expire, they will not be replaced as soon. So eventually, over time, we'll reduce the number of supported LTS kernels from 6 to 2. So that could be a problem if you. So there are a lot of companies that have kind of, especially in embedded, that are using older kernels, and so your support is going to drop after 2 years, or at least the upstream support. So you may need to look for a different source for your support to get your security bug fixes and things like that. So there are some projects that maintain kernels for a long time, like CIP or Ubuntu LTS. Both of those projects plan to support kernels for 10 years. But anyway, you need to pay attention to that if you want to keep your products up to date and continue adding kind of bug fixes from upstream. So this is actually not this week, but as of March, I think I took this snapshot. Oh no, I took it relatively recently. Took it on February. Oh, I took it on March 1st, I think. Anyway, mainline when I took this snapshot was at 6.8. This is just a screenshot of kernel.org, and you can see the long-term versions and when they were last updated. So this all makes sense. The current released kernel, the stable kernel right now is 6.7. It may have anyway. So if you ever, this is just a resource I threw on here because if you want to know about any particular thing, so I took a screenshot. I was doing research on shadow stacks, and over a period of a number of years, the LWN.net which is an online kind of news reporting site for the Linux kernel, they've had a number of articles on shadow stacks. And so you can see this is an excellent resource for finding information about any particular kernel technology, especially the new ones that crop up. You can see I did a search and got some hits on shadow stack, and so you can really figure out what's going on with a system because of the good reporting there and the articles that are written. Okay, so that was kind of longer than I had hoped, but we'll go into technology areas and talk about individual areas. So some of these I've already talked about, but these are the main things I want to cover. In terms of architecture, there's a new processor architecture out of China called LungArch that has been added, and it's been getting a lot more support. You'll see a lot of kernels. They're trying to catch up to kind of the support level of other architectures that are already upstream. And then also same thing with RISC-V, but they're a little bit farther along. RISC-V support is becoming very, very mature. As I mentioned before, a lot of old ARM boards support for ARM boards was recently removed. And then old architectures are also getting removed, whole architectures like Super H and Artanium. In terms of bootloaders, just a couple of interesting things. So U-Boot now has an option that supports loading images over HTTP. So this was previously U-Boot only supported the UDP protocol. So you could only use NFS or TFTP, but they've actually added kind of TCP and support all the way up to HTTP. So you can put your kernel and other images such as your DTP or your init-rd on a web server. So that's actually pretty cool. It includes a new binman tool for packaging and managing firmware images. U-Boot has improved support for tracing firmware handoff. And also you can compile it with LTO, which is link time optimization. So you can get a smaller version or a smaller image. Anyway, if you want to see about that, there was a good ELC 2023 session by Simon Glass, and that was reported on by LWN.net. So if you're interested in bootloader stuff, or particularly U-Boot. The other thing that came out this last year was a set of tools called SnagBoot. And that set of tools helps help you boot and install images on boards that fail to boot. So sometimes you're working with a board and for one reason or another, it stops being able to boot. And so this allows you to kind of access the bootloader and using a variety of different methods, figures out which one to use and either uses DFU or USB mass storage or fastboot. You can reflash the image. So this is a way to kind of recover boards that have gotten into a non-booting state. The great thing about this is it works on several different boards and replaces proprietary tools. So it's often the case that the flash tools for a particular board are proprietary. They're custom to that board. You get them from the manufacturer. So this is a project to try and create kind of an open source and an open set of technologies for doing this that works on multiple boards. So it's not specific to a single board. Anyway, so that's a good project to take a look at if it applies to you. Let's see here. In terms of boot time reduction, the biggest project that I see active work on is uRead-Ahead. This was reported on at ELC, Embedded Linux Conference, over the summer. And also we talked about this a little bit at Plumbers in September. But there's a good presentation on this. The Chromebook team has been using this. It used to be a part of Ubuntu, but Ubuntu stopped working on it or stopped developing it. And so it kind of went inactive. I mean, people were using it behind the scenes, but there was the public source code or database for this repo was not active. So, but they want to, the people at Chromebook, in particular Steve Rostedt, want to revive this and have a nice public upstream project that's active. So, um, and what this does, you read ahead, allows you to pull pages into memory before when they're needed. So you can specify to the system on startup to pull in pages, and so they're already in the cache when they're needed by a process. There was also some other discussion at Plumbers about boot time. So TI presented a number of different ideas for how they're approaching boot time reduction for automotive cases. And so I would, if you're interested in working on boot time, I highly recommend looking at this talk, which was presented at Plumbers, Resolve and Standardize Early Access to Hardware for Automotive Industry with Linux. They talked about a couple of different techniques, a custom bootloader, and then one of the big problems is that a lot of specialized MCUs, microcontrollers, are used to start hardware before Linux boots. But then you need some kind of handoff. And they're saying it'd be nice to create some standards for how that handoff occurs to make it more performant. And so there's a lot of good ideas they have there. In terms of the core kernel, the main thing I saw here was kernel same page merging. I'm not sure how much this is used in embedded, but it 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 this is a system that allows you to run a kernel with using less memory. Same page merging means that the kernel will automatically find pages that have the same data in them, and will map them, create virtual maps that virtual pages that map to the same physical page, and that reduces physical memory footprint. So there are some workloads where this works really well. Anyway, there's been some improvements on how those pages are scanned for, some auto tuning, and so if you're interested in kind of this memory technique for reducing the amount of memory you're using, that's something that was just added. In terms of graphics, there's been some GPU work on both the Panfrost driver and the NVIDIA driver, open source drivers for, of course, AMD continues to do a lot of GPU work in the open, but NVIDIA usually doesn't. And so this was kind of interesting news. Just last month, Collabora announced that they have got a open source driver for NVIDIA chipsets that is ready for primetime use. So there's been a lot of development over the years on kind of experimental, but they've actually, it's suitable to be integrated with like Mesa and other parts of the GPU stack or the graphics stack. So if you're using an NVIDIA GPU, it's nice to finally have an open source driver for that. I don't know if it covers all NVIDIA chipsets or just specific ones, but you can look up the information there. In terms of file systems, there was some work on memory technology devices, SPI NOR. So there's still people who are not using, or are using kind of raw flash. So there's was enhanced locking to support reads while writing, some enhancements to the extended read-only file system. And then the big piece of news here, I thought, for file system performance was block IO speedup. So this is a set of patches that haven't, that I think are queued for version 6.9, but the developer found some things that could be cached in the block IO performance path. So when you're doing IO, there's kind of a series of steps you do, and he noticed that there was a lot of time spent trying to get the system time. So the system time is often added to the IO operations as part of the processing. But the resolution of those times was not needed to be as high as it was. So he decided, well, I can cache the time. Uh, and if it's within a couple of microseconds or nanoseconds, that's close enough. And so instead of doing thousands of time lookups for a set of operations, he could just cache the time. Um, Anyway, this yields about a 6% performance improvement. And the developer who wrote it said, I've been thinking about this for years, and it only took me about 5 minutes to write. And I kind of am embarrassed that I didn't do it sooner. Um, so that's a nice file system speed improvement. In terms of languages, I'll just talk really quickly about Python. So Python, I think the biggest news on this one, they've been working a lot on speed. But Python 30.13 will have a just-in-time compiler. So that should, I haven't seen any benchmarks for what this is going to do to speed up. So in Python 11, they were doing a lot of speed ups, and they've added some specializing things to the interpreter. But in 3.13, we'll actually have a JIT. So there'll be some native code running as part of Python, not just the interpreter, but stuff will actually get compiled down to native code. So we'll have to see what that does for performance. So 3.13 is not out yet, but it's coming fairly soon. And then Rust. So we finally have an example of a real driver in the mainline kernel in 6.8. I mentioned that earlier. We also have, this showed up in November, actually a Rust implementation of Android's binder. So this is kernel code that does an Android-specific IPC mechanism. That has not been mainlined yet, but it turns out that binder as an IPC mechanism it was originally written in C and had a lot of vulnerabilities, kind of the normal types of vulnerabilities you see in C code, use after free or things like that. And Rust solves a lot of those. In fact, the person who did this implementation said that it actually fixed 50% of the vulnerabilities that had been reported on the C1 were simply not possible because of Rust, how Rust dealt with memory and things. So in terms of overall support for Rust, there's still a huge debate going on in the Linux kernel community about whether this is positive or negative. So some people are not very happy to see a new language introduced. They say it'll really complicate things for developers, particularly developers who work on across subsystems, because now they have to know two languages, and in particular, they have to know a new language with some very kind of difficult semantics. But people are saying, well, the security might be worth it, and some people definitely want to go this direction to try and improve the kernel. So we'll see what happens. And then finally, just Rust 1.76 was released on February 8th. So Rust continues to develop, and we'll see what happens with the mainline kernel as more people put code in. There are some maintainers who are quite excited about the capabilities that Rust provides. So we'll see what happens. Let's see, in terms of networking, I'll just say that there's a lot of industries are moving from proprietary networks to Ethernet. And there was a really good talk at Embedded Linux Conference about the different features for some of the newer features on Ethernet, power over Ethernet, power over data line, single wire Ethernet, and in particular, single wire Ethernet is used in automotive, and so then there's a lot of reasons for that. Anyway, let's see. Okay, so let's talk about real-time. So everybody always wants to know what's the status of real-time patches. So the preempt RT status, I'll talk through that, and then I'll talk a little bit about Zenimi, which is the other alternative. So what's left in the preempt RT patches? So I actually just took a look at this today. last year, sometime in the fall, I think in October or November, I was looking at it, and there were 79 files. There were 91 patches, 79 files, 2,800 lines of code. And this year, as of today, there's 118 patches. So we've gotten more patches. It's affecting 87 files, affecting more files. It's still about 2,800 lines of code, which is not very much. If you are applying patches to the Linux kernel, 2,800, 100 patches and 2,800 lines of code, that's not a lot. If you look at where they are, 52 of those patches are just for printk. And that is the single biggest thing that needs to be fixed before we can just kind of turn it on. There will always be some printk patches in the queue, or there'll always be some real-time patches in the queue, because there's always things that kind of need to be fixed and addressed. So, but Thomas Gleixner said at Plumbers, this was in September, that the printk changes are the ones that are kind of the blocker. And then as soon as the printk changes are in, that will basically declare that you can now enable preempt RT in the mainline kernel. So if you want to go look at those, you can go look at that. But it's getting very close. I think it's basically suitable for. I mean, it's been suitable for use for a long time, but you can. The number of patches is pretty easy to apply. Also, I noticed this particular time, the patches are much better organized. If you look in the series file, this comes as a patch series, and they've done a really good job of kind of organizing the patches so you can see where they all go. It was much easier to analyze this time than it has been for me in the past. And then if you want to kind of see the details of this, the most recent up to date status is from Thomas Gleixner. And this again was from a talk, I believe, at Plumbers, where he talked about the RT preemption endgame. So if you want to kind of see what's going on with that, you can follow those resources. The other way to do real time in the kernel is with Xenami, which is kind of the dual kernel approach. And you have essentially a hard real-time kernel with Linux running to the side of that or on top of that. And this has its own pros and cons. I'm not going to go into them, but that continues to be supported and developed. Okay, couple of security things, and I'll try to be watching my time here. We have shadow stacks that I already discussed. There was some work to remove elf notes from sysfs, or rather to adjust the elf note. So there's something in the kernel called kernel address space layout relocation or randomization, or I call it kernel address randomization. It turns out that so they randomize where stuff lands in the address space to make it harder to attack the kernel. So if you don't know what the addresses are for instance, all the functions, then you can't do return-oriented program attacks. It turns out that they were leaking a lot of the relocated kernel addresses in sysfs because there's a section called elf notes. So some of and they were actually relocating the addresses in those elf notes. Those are elf sections have to do with the module and the binary addresses, well, binary image addresses and stuff. Anyway, so there have been some patches to fix that, so we're not leaking those relocated addresses anymore. And then BPF raises some interesting security issues. If you can run a process at runtime inside the kernel, then obviously you can do a lot of stuff. There's been talk about allowing unprivileged users to run BPF modules. I don't think that's a good idea. I think requiring people to be root is probably better. But anyway, the people are looking at it. In system size, I already kind of talked about this. The slob memory allocator was removed. I thought they didn't give people enough time to respond to that. It was deprecated in 6.2, and then just within 5 months, just 2 releases later, they actually removed it, yanked it out. So I don't know if I have to say though, I don't know of anyone who is actually using this. So maybe it was good to get rid of. They just didn't want to maintain it anymore. And then they said when they did that, hey, we're going to get rid of the slab memory allocator. So watch out for that too. And sure enough, they did. In 6.8, it's removed. So only the SLUB allocator remains in the kernel. There is an option to use this on small systems. So if you use config slub tiny, you can use it on small systems, and it's not going to be as efficient as slob, but it will try to reduce its footprint. So that's a little bit sad to me that we've lost those memory allocators that were designed specifically for low-end systems. But that's the way it goes. In terms of testing, I think I'm going to skip over these. I think most people know about these Linux test projects, K-self-test and K-unit. So Linux test project is outside the kernel. Its latest release was just in January. And I'll let you look at the slides for this. I'm not going to go over the details here. But K-self-test is inside the kernel. Some of the recent things where there's a new proposals to add metadata to the data for the test and to kind of standardize that. So KTAP, which is the standardized, well, TAP stands for Test Anything Protocol, and it's the standardized output for tests. And there's a special version of that called KTAP for the kernel. Anyway, they've never, what they want to do is they want to establish a set of well-known tags to specify metadata for the tests, which will help in filtering tests and analyzing results. Anyway, if you want to look that up, there was a plumber's talk on that. And then K-unit is for unit testing. I'm not going to go into the details here. So there were two things that are happening really recently, though, that I want to talk about. So there was this new proposal to specify in the maintainers file the recommended test for a subsystem. So that is actually really interesting, I thought. It was suggested by Nikolai Kondrashov, and this is still under developer. He sent an RFC, and he has the patches for this. Got some feedback. I don't know if he's going to do another release or not of the patches, but it's not upstream yet. But I think this would be really cool. So you could eventually see. So this right now would be just to suggest a test to run. But eventually you could see that maybe it would be a requirement, but when you're submitting patches, that you would have to add a tested with tag to indicate that, yeah, I ran the tests that are associated with this subsystem. So the ultimate goal is for contributors to more easily test their patches, because there's a field right in the maintainers file to tell you what test you should be running and with what arguments and etc. And so it's supposed to also help maintainers so they can verify that someone has actually run that test. So that's one thing. The other thing that was just submitted was GitLab CI testing pipelines. So Collabora has actually submitted some patches to Linux kernel that have some GitLab CI pipelines. Consists of YAML files and shell scripts. So sometime in the near future, if this gets accepted, it would be really neat, I think, if you happen to be using GitLab, you could just point it at some kernels at some files inside your kernel tree, and it would run the static checks. Right now, it supports static checks, smatch, and check patch, but you could run other things. So if this kind of takes off, it means that you'll have a compatibility with continuous integration systems directly in the upstream kernel source. So that's pretty cool, I think. In terms of tool chains, GCC 13.2 was released. Okay, and you can read about that there. LLVM 1706 was released. There's some of the things that are going on with that. Sorry. I will definitely make these slides available as a PDF, so I'll send that out. We'll get it uploaded probably to the eLinux Wiki or somewhere else. So you don't have to jot this all down. I'm sorry, I'm going too fast to kind of see all this. If you're interested in what's going on with tool chains, you can see this talk or look up the talk Tool Chain Options in 2023 that was given by Bernard Rosenkranzer. And so and there's links to the talk and the video right there. Tracing. Okay, there's always something going on with perf. Perf is always extending. So the example is the perf data type tracing that I talked about previously. In terms of eBPF, there's a new report out by the Linux Foundation. So it turns out, I didn't even know this, and I'm on the Linux Foundation Board of Directors, is that there's an eBPF consortium or project that's one of the Linux Foundation projects, and they've just released a report talking about eBPF. So if you're new to it or you need some convincing, go to this webpage and learn about it. In terms of kind of news about eBPF, you can use it for tracing and monitoring, including itself. So Netflix has released a new program called BPF Top for monitoring BPF programs. So you can use BPF to monitor all the other BPF programs that are running on your system. So I don't know how many, again, embedded people are using BPF, but anyway. Yocto project had a release in November with a lot of upgrades, a lot of enhancements to run QEMU, a bunch of other changes. You can look at the release notes for that. Kernel community. This is an interesting one. So I think this is my last one too. Yeah, okay. So the Linux kernel community has become a certified number authority, or maybe that's certified naming authority. I could be wrong. Anyway, it turns out that you have to do that if you want to manage your own CVE naming or numbering. So the CVE assignment is fraught with kind of weird issues. It's often the case that the project members for a particular software project disagree with the impact and severity assessments of the CVE submitter or the CVE organization. And so it turns out that if you register yourself, that should be CNA, not CAN, Certified Number Authority, then you can control that process. You can have more input into that process. And so there's actually going to be some documentation in the kernel tree talking about this. And 3 people, Lee Jones, Sasha Levine, and Greg Crow-Hartman, are signed up as kind of the official people who are part of that CNA. The glibc project has also become a CNA for itself, and the curl project has also become a CNA. I guess this is, people have been complaining about how CVEs are assigned and that they're kind of bogus, or some of them are bogus. So this is a method to kind of deal with that and have more input into the CVE assignment process. So hopefully this will make things better. That's the hope. Okay, industry news. I don't have a ton of time, but I'll go through a couple. Just a couple of interesting things. So an update on the SFC versus Visio. This is a lawsuit. So SFC is the Software Freedom Conservancy. This is important because the SFC is asserting a very novel interpretation of the GPL. They're asserting something called third-party beneficiary rights. If the judge agrees with them, that this would allow any third party to enforce the license. So I got to be honest with you, I'm kind of hoping that the judge does not agree with them. They have kind of a weird interpretation of one of the clauses in the GPL, and this would open up the door wide open to all kinds of crazy things happening with litigation under the GPL. The other thing that they're asserting is that the GPL is a contract, not a license. That's kind of a requirement for them to assert this other thing. The latest update, so this case has been going on for, I think, over 2 years now. but the judge denied Vizio's motion for summary judgment. So this is normal legal stuff. Uh, the defendant always tries to go for summary judgment and get the case dismissed. The judge said no. But if you look at what happened, though, it's kind of concerning because it appears that the judge does plan to interpret the GPL as contract. So there's no, what legal terms, something called preemption by copyright law. Vizio tried to move this to federal court where they could try it as a copyright law case, but they failed. Anyway, the trial for this is likely in June 2024. This is just a case to watch if you're concerned about companies litigating you over the GPL. Anyway, random note. Yeah, in the U.S., this is interesting. So I just heard this the other week. Walmart is actually trying to acquire Vizio. So I don't know if Walmart knows they've got that kind of this legal thing pending. I'm sure they do. The due diligence. But that's the update on that. So a little bit concerning. OpenWRT project is designing its own hardware. So the OpenWRT project is now 20 years old. It was originally based on Linksys router software. And they've been making kind of router software for all kinds of commercial routers. So people take the commercial software off and put on the OpenWRT software, and they have a lot more control over how the router works and what features it has. And they actually have decided they want to create their own standard hardware, reference hardware. So they're making an OpenWRT1 board with the help from the organization that makes Banana Pi. So they want to make a fully open system. So basically they want to make so that users don't have any proprietary firmware anywhere in the system. So that's kind of interesting. I wish them luck. And then here's the other side of this. It turns out that HDMI 2.1 can't have an open source driver. So just recently, the HDMI forum told AMD that it is not allowed to make an open source driver for HDMI 2.1. This has been an issue that's fairly common in embedded, well, just for Linux drivers in general, not just embedded, which is that there's some organization that controls a standard, and in order to get access to the standard, you either have to join the organization or pay fees, and they put you under NDA so you can't release the information publicly. And if you write an open source driver, of course, that means that you're releasing the information to the public. So this happens actually, or used to happen a lot more. It's kind of disappointing in this day and age. I don't know of a TV in the world that's not running Linux these days. And so what it means is that, I mean, obviously HDMI drivers exist already in Linux, but HDMI 2.1, or 2.1 plus, is the latest standard. Means that Linux users can't use the highest resolution frame rates with open source drivers. And so this is annoying. It's a big problem for GPU drivers. So a lot of GPU drivers often include the audio driver for technology for HDMI support, and so or the video driver. So GPU drivers, in particular AMD, can't write an open source driver for their own hardware, which is annoying. This has actually been an ongoing problem for a long time. But it was just reported on recently. Just because I'm a space nut, I always like to talk about what's going on in space. So I'm going to talk about interesting embedded Linux use cases. So Linux is being used in a ton of satellites, all the way since 2003. It's been 20 years since Linux has gone into satellites. Not all of them, but a lot of them, especially CubeSats. It's estimated that about 50% of CubeSats, which are the smallest ones, run Linux in some part of their flight stack. And then some of the major constellations, the two largest satellite constellations are Starlink and Planet, and they both use Linux. So Starlink, each Starlink satellite has over 80 processors. The new ones have over 80. The V ones only had 66, I think. But each one is running Linux, and they're using clusters of Linux. The reason they have so many is they have these clusters for fault tolerance. And it's a telephone switch, right, in outer space, or it's it's a data switch out in outer space. But there's now over 55 100 Starlink satellites currently in orbit. That means there's over 400,000 nodes of hardware running Linux in orbit right now. And that doesn't even count Planet's constellation, which is pretty big too. Not as big as this. I think Planet is like 100 or so. Um, there was a really interesting talk. If you're interested in this stuff in space, or even if you're interested in kind of upgrade mechanisms, there was a talk at the Small Satellite Conference that I happened to catch, talking about how Starlink does their fleet upgrades. So it's very, very interesting. They have a single image that they upload to each satellite. And of course, because the satellite is not uh, physically accessible from the ground, this has to work like guaranteed work. Otherwise, you've just burned several $1 million device. But anyway, the way they do their updates, I thought was really interesting. And if you're interested in that, go check out their slides. So Falcon 9 and Starship both use Linux. And then the Mars helicopter, this uses Linux. Or unfortunately, I have to use the past tense. It used Linux because as of Flight 72 in January, the helicopter broke its blades on one of its landings and it can no longer fly. So NASA announced the end of this mission. Uh, there's an animation of, I think, one of its first missions, and then they caught a picture of it with its blade broken out on a sand dune on Mars. So that's the end. Well, so Linux is still on there, and I think it probably still wakes up. It has enough power to wake up every night. So Linux is still running on Mars, but NASA has officially announced the end of that mission. So kind of say farewell to our interesting. And then this is okay. So I have to apologize. This is not Linux, but it is open source. So this is running NetX. The Sora Q transformable lunar rover was landed on the moon just recently. Was it February, January, February? Anyway, but the reason I'm so excited about this, of course, is because Sony is involved with it. So JAXA, Tomy, Sony, and Doshisha University worked on this little rover, and it took one of the most awesome space pictures. It's been nominated for Space Picture of the Year, and it's only February. But anyway, and that was with a Sony camera, of course. Sony image sensor, but the main processor board on this was a board that Sony had done that was running NetX. So we've got open source up on the moon. And so, of course, after the lunar night, none of this stuff runs anymore. But, Slim woke up, so that was pretty cool. Anyway, congratulations to everyone who worked on that. That's really cool. Again, I'm a space nut, so I watch this stuff. I'll go talk about kind of conferences. So the Embedded Linux Conference, just an update. It's now back to twice a year. We experimented with trying to do it only once a year. We only did one ELC in 2023. That was in Prague. And it turned out that it was a good one. It was a good event, but there was demand to do it in both places. So we were only going to do it once in the US this year, but some people requested that we do it they didn't want to not have it in Europe. So we're actually going to be doing a mini ELC in Vienna in September. And then also I'm planning on doing a micro conference at Plumbers, embedded micro conference at Plumbers. So that's just like a half day event with some embedded content, also in Vienna. So if you want to see some of the presentations, all the presentations and videos are now online from Embedded Linux 2023. That was way back in June. And then here's some of the other ones that have happened. We had Embedded Open Source Summit that had those at Japan Technical Jamboree. The first one from episode 2, phase 2 of the Japan Jamboree was September 29th. We had Embedded Recipes, Linux Plumbers, where we had an embedded BOF. And then FOSDEM had a nice embedded track. Linaro Connect is coming up in May, and Plumbers is coming up in September. So now the next set of slides was kind of details for the leadership summit that I held in Prague. But because I'm running short on time, I want to kind of finish up by, I think it's 11:30 your time. I'm going to skip over these slides. You can look at it. So I have two sets of slides in here. One talking about some of the discussions we had at the Embedded Linux Leadership Summit. So this was leaders in embedded Linux, consisting of companies, product vendors, trade associations, project leaders, and consulting companies. And we tried to come up with a list of areas that we needed to work on. And this is the list we came up with. Security, over-the-air updates, long-term support, heterogeneous core support, shared testing, safety critical and certification, and you can see all the others. So these are things that we still think we need to work on in order to make embedded Linux better for everyone. And then we had at Plumbers, which was in September, we had an embedded Linux BOF. And then I have a summary of all the major topics we discussed in the next few slides, but I'm going to zip over those. So I apologize for not covering them because I'm taking too long here. But we did a survey of okay, I'm going to cover them real quickly. We did a survey of kind of the most interested areas, what areas of embedded Linux people are most interested in. Architecture and tools and distros came out on top. We talked about bootloaders and boot time, whether or not XIP is still a thing. Let's see, why is embedded systems so hard? Is anyone still using MTD devices? Let's see. Arndt Bergman, who's the ARM maintainer, asked if 32-bit is still being used, and every single person in the room said, "Oh, yeah, we still got 32-bit, so don't get rid of it." So anyway, well, let's see. Okay. Sorry, that was so quick. Just real quickly, if you're interested in an embedded Linux, you should get on, especially upstream discussions. There is a mailing list for Linux embedded at vjr.kernel.org. This is the official kernel embedded mailing list. It's not used very much, but I think we should use it more. And then if you want to discuss strategy and community building, there's a brand new list called elinux-discuss. That's at lists.elinux.org. Speaking of eLinux, I'll get to that later. Let's see. Okay, that was the embedded BOF. Okay, so eLinux Wiki. So this is a place where we have information about embedded Linux, tools and technology. It suffered a little bit of a crisis because the organization that was funding this is terminating, but the Linux Foundation has hired Bill Trainer, who was the eLinux administrator, as a full-time employee. So he's going to do eLinux administration as part of his job. So that means the site is still funded. Some of the areas of the site are out of date, but I actually saw a reference just today when I was doing research for this talk. I saw people referring to pages on there. So there's a lot of good information still out there, including all of the talks, the slides, and the videos for all of the Embedded Linux Conference talks. So it's still a very valuable site. We've actually set up a crowdfunding site so that we can fund activities for it. We were planning on funding the administration, but now the Linux Foundation is going to cover that. So we're figuring out what we're going to do with the funding that we have. And then the trade associations and projects. Again, this is a long thing talking about all the different projects that are going on. And I'm not going to cover all of them. The Linux Foundation has all these different projects related to embedded that are active, except for the third one there. The core embedded Linux project is shutting down, but automotive grade Linux is going strong. CIP, civil infrastructure platform, drone code, ELIZA, kernel CI, OpenChain, OpenSSF, Yocto project are all very, very active and working on They're things, and I have details about all of those. So I'm just going to cut right to conclusions. Overall, we're doing very well. There's a lot, as you can see from the discussions from the Embedded Linux Leadership Summit, there's a lot of areas that still need a lot of work. But embedded Linux is widely deployed and it's very functional. It's literally in billions of devices. So the core kernel systems are in place to support embedded. Cross-compilation works, testing works, and we have maintainers in lots of areas. And actually, a large amount of progress has been made getting SoC support upstream. So processor support in embedded is better than it's ever been. But new hardware always keeps being made, and we'll always have things to write and upstream. So we're not done just yet. One thing that came up a lot in discussions at Plumbers was that more investment is needed by users of embedded Linux in the infrastructure and the community ecosystem. So if you're using Yocto project, make sure that you contribute to that. If you're using embedded Linux, contribute what you can upstream. And I guess my question to you is, what do you think is missing to support embedded development? What would you like to see in the future? And if you have some ideas on that, get on the list that I talked about, or just send me an email. I'm always interested to hear. So thank you very much for your time. And with that, I will answer any questions that you have.
Thank you, Tim. 質問とかある人いますか？そうだね。もらっておくようにします。リモートの人も質問あれば。
Hi, Tim.
Hi.
Hello, I'm Masami.
Yeah.
And so you were say that talked about that the DL server, deadline server series.
Yeah.
So do you think that that will improve something like RT or performance or something like that?
I don't know. I have not worked directly on real-time myself for a while. It really is to address a specific kind of failure mode, I would say, which is when your real-time processes oversaturate the CPU. And in my opinion, that shouldn't happen if you've tuned your real-time properly. So I don't know how much it happens in practice. I think it's the way it was described in like the patch submissions and like the LWN.net articles. It sounded like this was something that the real-time experts were concerned about. Basically, the improvement that it has over real-time throttling, which was the previous way that they handled this, is that the system, I guess, previously real-time throttle essentially took 5% of the CPU, whether it was needed or not. So even if you were not in kind of a starvation mode, it would take 5% of the CPU. And they said, well, we don't want to waste 5% of the CPU overhead on a case that's not used. But it seems like, I mean, my opinion, if you have a real-time system and you're using more than 95% of the CPU, you're probably doing something wrong, because you should have, in my opinion, you should have much more kind of slack in your system. So it's hard for me to gauge how important it is, but the real-time people seem to like it a lot. So
Yeah,
anyway.
but sometimes it's hard to let's say that design that are correctly designed that are that out the real time let's say that are real time percentage or something like that, because
Right, right.
if we have many running that are some different let's say real time systems on the same system, we will sometimes you need to use that or like a C groups or something like that.
Right.
And we don't know that how we can let's say control that the percentage of their outiness.
Right.
Sometimes it's over 100%, and
Yeah.
yeah,
Yeah, if you get into a situation where you're overcommitting the CPU, then it seems like a nice solution to allow you to recover from that, because of the scheduling priority it's using, you're guaranteed to be able to get out of it. Whereas I guess with the real-time throttling, that wasn't always the case. So
mm. And also, did you or saw that something like the KVM real timeness discussion?
I seems like I vaguely recall something. I didn't look at it recently. It seems like there was some real-time KVM stuff at Plumbers, but I don't remember. I didn't attend the real-time track because I was hanging out in the testing track. But
Uh,
but yeah, there's a lot of stuff going on with real-time and real-time with KVM, which I find I don't know. I find shocking. If I was doing a hard real-time system, I'd not be using, like a virtual machine, but
yeah, sometimes it's our case that we need to run our Android system on their
oh yeah.
and some Android audio system needs to run our real time.
Yeah. No, there was actually a really good now that I think about it, there was a really good talk by Daniel Bristott Oliver at ELC,
Yeah.
where he talked about he actually did some good benchmarking between uh, virtualized systems and regular systems and what some of the issues were. So that's a good one to look up.
Yeah. Okay. Thank you. And
Sure.
one more. Do you have any what's it that special what's an interesting topic about the testing?
You mean me personally?
Yeah.
Well, I'm the maintainer for the Fuego system, so I got really interested in test standards. So I tend to follow what's going on with like K-self test and LTP and like this GitLab CI stuff. I just thought was really interesting, and some of the new initiatives to improve the kind of the testing in the Linux kernel.
Okay. Thank you very much.
Yeah.
他何かありますか？リモートも大丈夫かな？
Hi, Tim.
Hi.
Yeah. So I have one question. So I have not catched up about the updates of muscle libc for a long time, and so what the main use case of it, especially in embedded?
Of muscle.
Muscle, yeah.
I don't know. I mean, in Sony's products, we're using glibc pretty much everywhere, but I have heard a lot of people switching over to muscle. Uh, and I was interested when I saw that muscle was up to date with like well, not up to date, but they were working on shadow stacks already. So I think, I mean, from what I can tell, it's a very capable C library. You know, it's always easier to use glibc because it's what everybody else is using, and you know, it's got more testing and that. But my understanding, I mean, Muscle is fully supported in Yocto, and I think I'm not positive, but I think it's fully supported in Buildroot as well. So I know a lot of developers who use it and are very happy with it. It has a smaller footprint. I don't know how that translates into like performance. Usually, if you have a smaller footprint, it's a little bit better performance just because of caching and stuff. But its main claim to fame is that it just allows you to build a smaller embedded system. But it depends, right? It's like these days, I'm not sure you need, you know, to be 5 meg smaller, 3 meg smaller, whatever it is, difference between it and glibc. So.
Yeah. Yes. Okay. I see. Thank you.
他ありますか？ Okay, thank you, team.
Okay. Thank you very much.
拍手を。
Okay, yeah, I'll have to ask you how to upload my slides.